already have. April Webb is with Scantra. She did the pre-construction sort of services and pricing efforts for us. We also partnered with WSP, who is essentially our envelope consultant. And then Daniel Mooring with IBC Engineering, who provided MEP services as well as some financial infrastructure information as well.
So one of the things that was especially important to us was considering the state of affordable housing in DC, and some quick numbers. You can see the numbers on the slide. In addition, about 1,000 units have been lost of affordable housing between 2004 and 2015. Another 1,700 or 1,800 are at risk of being lost, and then another about 14,000, which now get subsidies, may lose those subsidies by 2020. I think we all recognize that pressures on development in all of these neighborhoods, which may originally have been affordable, are getting greater and greater. So maintaining affordability is key to the city for many of us. And so that's the challenge. I will say that early this year, the mayor committed to supporting affordable housing, and $90 million were committed to about 12 projects. So the good news is that we are in a city that's committed to affordable housing. I think we have people in the audience that share that view. So that's one piece of the puzzle.
Yeah, so at the same time, there's all this pressure on affordability. Just the very presence of affordable quality housing we thought was really important. So we tried to maximize, put in as many units as possible and make them all affordable as part of sort of the social equity component of sustainability. And as we know, the district is certainly a leader in sustainability and has very ambitious goals that we have been making progress on incrementally, but to really get to the really ambitious carbon reduction and energy reduction targets that we wanted, it's going to be complicated because of the nature of the district's economy. And this is from the district's greenhouse gas emission inventory. And as you can see, the different stacks of the bars represent the different sources. And overwhelmingly, the takeaway here is that a lot of the district's energy use and carbon emissions are not driven by the resident population. They're driven by the commercial sector and the government sector, which of course drives the economy. So in order to not make this a zero-sum game, if we're going to continue to have places like Washington Hospital Center, which is a huge user of energy, and still meet the overall district-wide sustainability goals, it means that we have to take whole blocks off the grid. And that's really how we approach this question, is going really beyond code and also maintaining or trying to defray the cost premium of that.
So this is our site, 57th and Dick Street. And if you just take a quick look at the image of the aerial view, you can see that it's not that densely populated. Beyond, you can see, you may not be able to see, but the metro is about a mile away. It's at the head of the Marvin Gaye Trail, so another sort of opportunity that we saw at the site. And then beyond that, we actually wanted to tie into, you want to go to the next slide? Here again, fortunately for us, the Office of Planning has done a lot of work to look at all of the neighborhoods around the city and to figure out ways in which we can project forward in their development. And what was very interesting to us is the pink zone of commercial development. We saw our project site within that context, that Dick Street itself had this potential to bring some retail down, and it would be at a scale of sort of corner store, but we wanted that to be part of our story and part of the way that we thought about the site.
So in addition to sort of taking a physical analysis of what was around the site, we also looked at doing climate analysis. So on the psychrometric chart, which measures temperature, humidity, and a lot of other things, we sort of look at what is the comfort zone. And the times of the year that we're in the comfort zone in DC is very minimal. It's either cold and dry or hot and humid. So the idea is that if you can expand that comfort zone with design, that's less time that you need to mechanically heat a bigger structure. And there are a few strategies in DC that are particularly meaningful to use and incorporate. The first is passive solar heating. The second is thermal mass effects. And lastly is natural ventilation. So if we can incorporate all of those strategies into our design, the times of the year in which we need to use mechanical cooling is greatly reduced. And that, of course, helps with the net zero goal. We also took a good look at wind analysis. and we understood that most of the prevailing winds come from the south, and that's in both the summer and the winter. So in the summer, you want to let those breezes in, but in the winter, you want to block those harsh winds. So it's sort of this double-edged sword you can play with.
Great, and then, after we sort of tried to, through design, minimize the need for energy and water, we had to really look at what the site was itself and what it could provide, because we couldn't have anything that wasn't available on this 32,000 square foot lot. So I just looked, based on historical climate data, precipitation, both annually and monthly, to determine the carrying capacity as far as energy and water on the site goes, and it was tough because residential uses consume a lot of water. Average American uses 100 gallons per person per day, but we only had about 770,000 gallons that fall over the course of the year. At the same time, it was about 650,000 kilowatt hours that were recoverable. I mean, if we just blanketed the entire place in solar panels, which was obviously not the design aesthetic, but that kind of established our bounds that we could then overlay the supply curves on what the demand curves would be as far as the building, and then use design and technology to try to mediate those two things. And overwhelmingly, what we're trying to do is really flip the concept that, this is something that was being given, or that this is, rather than a subsidy, it's a source of investment that we can make an actual asset for the people that live there. So reprogramming energy subsidies and housing subsidies into actual sources of wealth. So just to get a little bit more specific again, the variability of the water flow meant that we would have to capture as much rainwater as we possibly could and store it, and then use it for potable and non-potable purposes. And again, through a variety of passive and active strategies, we really tried to cut down the baseline of energy consumption that would be required, because we wanted to, we had to produce more energy than would be consumed in order to be able to store energy for resilience purposes. But also, because the solar market in DC is so hot, we really looked at that as an opportunity to oversize our system and use the leverage from the very attractive solar credits to balance off the high cost factors that we needed to capitalize just to hit the performance targets. So getting to net zero, this is directly from the district's net zero energy financial report, which is a real page turner if you haven't picked it up. Actually, it is actually really good. I know the audience here, you guys came out on Monday to an architecture lecture. So. But the basic concept is that, design is better than technology, and by really understanding the place where you are and using the forces that are there, you don't have to actively fight against it. And just from the analysis, which was for a different type of building, and it was a larger building and different applications, a lot of it is through, 59% of the path to net zero was through deep energy efficiency. 35% is through scale jumping, which means going beyond the borders of the site to understand how to better leverage energy. And then only 6% was rooftop PV. So we had to incorporate all of those, and we'll tell you all about it.
Yeah, that's right. We're trying to limit how many times we went back and forth. So here again, the approach we wanted to take in terms of creating these single units, these 15 townhouses, was to make sure that the materials that we put into them and the way that they were designed would, over long term, serve the residents well. So it's part of the sustainability.
And I think one of the important things to note is that a living building is especially important for affordable design, because the idea is that it's not just affordable to build initially, but that it's affordable over the long term. So you can prevent people from having to pay an energy bill or a water bill, and that the materials last longer. There's less replacement that has to happen. So that's how you achieve affordability over the long term, which is great, and how the living building challenge relates to that. And so then looking specifically at our site plan design, we wanted something that really respected the urban fabric of DC. So we lined the block with our townhouses. It was important for our developer that we did include parking, even though it seems sort of unsustainable, but from a market perspective, that's something that is really desirable. But we did buffer the parking area from the townhouses with a constructive buffering. We have two public spaces or gathering spaces. One is on the southwest corner, which is more of a public space. The second is towards the northeast corner, which is a little bit more insular and meant for the residents of this development to use. As Holly mentioned earlier, our site is connected to the trailhead, the Market View Trail. So the community garden that we wanted to use is on the southwest corner, directly connected to that bike trail. Knowing that we were a bit removed from other sort of amenities, we thought the bike trail would be a nice connection to make to the surrounding area. We also have a outdoor gathering space for the community with tables and chairs. And I should have also mentioned that we have 15 townhouses that line the block, and 3 of those units are specifically designated as living room units. So the idea is that the ground floor is a flexible space that can be sort of altered over time as sort of a future land use plan to show that this street is meant to be sort of a residential or a retail corridor in the future. So this particular open space is flanked by those living room units with the idea that in the future, those ground floors can then be converted into sort of small mom and pop local retail. And then the more sort of insular open space meant for the residents specifically sort of has horseshoe pit, quiet green space, and we also have a separate structure that houses all of our mechanical systems. And this is really a big part of our idea is that that structure actually speaks to a lot of the educational components. There's a dashboard that will read readouts of how much energy each house is using. It's got glass, it's going to be color coded, and so that it would help the residents understand how much energy they're using and therefore create sort of this competitive loop where they start to use less because they see how much their neighbors using. And then on the southeast corner of the site, we also have that third live work unit and a small sort of open plaza space so that when that street does get developed, it sort of speaks to that. And then for the design of the townhouses in particular, we looked at vernacular design. So what historically has DC done and what can we do to work with that but in a more modern way. So the fire